To increase the chances of passing an electrical inspection, there are several high-level tips to keep in mind. Firstly, follow the National Electrical Code, or NEC. Ensure the installation complies with the latest version of the NEC. Secondly, use underwriter laboratories or all listed materials. All electrical components, outlets, switches, and wiring must be UL listed. Thirdly, size conductors properly. Calculate the correct wire size based on the amperage draw of the circuits. Use a wire size calculator or consult an electrician. Fourthly, use ground fault circuit interrupters or GFCIs. Install GFCIs in all areas where water is present, such as bathrooms, kitchens, and outdoor outlets. Fifthly, install arc fault circuit interrupters, or SIs. SIs are required in bedrooms and other areas where there is a risk of electrical fires. Sixthly, provide adequate circuit protection. Install appropriate circuit breakers or fuses to protect circuits from overloads. Seventhly, connect neutral and ground wires correctly. Ensure that the neutral and ground wires are connected properly at the main electrical panel and throughout the house. Eighthly, use electrical boxes properly. Electrical boxes must be the correct size for the number and size of conductors installed. Ninthly, label circuits clearly. Label each circuit at the circuit breaker or fuse panel with its intended use, such as kitchen outlets or lighting. Tenthly, obtain a permit and have the system inspected. Secure an electrical permit from the local building department before starting work. Schedule an inspection by a qualified electrician or building inspector once the system is installed. Some of the common problems identified by inspectors include incorrect wire size, missing or improper grounding, overloaded circuits, improper installation of GFCIs or SIs, unsecured electrical boxes, exposed or damaged wiring, absence of circuit labels, and a lack of documentation such as load calculations. It's important to understand the National Electrical Code, or NEC, which serves as the foundation for safe electrical installations. It's a comprehensive set of standards that dictate how electrical systems should be designed and installed. Compliance with the NEC is not merely a suggestion, it is a requirement for ensuring safety and code compliance. The NEC is updated regularly, typically every 3 years, to incorporate new technologies, address emerging safety concerns, and refine existing requirements. Using the latest edition is critical to staying up to date with the best practices in electrical safety. Many local jurisdictions adopt the NEC with or without local amendments, making it the de facto standard for electrical installations across the United States. Familiarizing yourself with the specific edition adopted in your area is the first step toward ensuring your installation meets the required standards. The NEC covers a wide range of topics, from wiring methods and overcurrent protection to grounding and equipment installation. Understanding the key sections of the NEC applicable to residential electrical systems is important for any electrical project. This includes understanding how to calculate circuit loads, determine appropriate wire sizes, select suitable overcurrent devices, and properly ground the electrical system. The NEC also provides detailed guidelines for specific installations such as bathrooms, kitchens, and outdoor areas where unique hazards may exist. In addition to following the NEC, using UL-listed materials is another key aspect of ensuring a safe and compliant electrical installation. UL, or Underwriters Laboratories, is an independent organization that tests products for safety. When a product is UL listed, it means that it has been tested and meets UL rigorous safety standards. Using UL listed electrical components such as outlets, switches, circuit breakers, and wiring provides assurance that the products have been evaluated for potential hazards such as fire, electric shock, and mechanical failure. UL listing is not a one-time event. UL conducts ongoing surveillance of manufacturing facilities to ensure that products continue to meet their safety standards. This ongoing surveillance helps to maintain the integrity of the UL listing and provides confidence in the safety of the products. When selecting electrical components, look for the UL mark on the product or packaging. The UL mark indicates that the product has been tested and certified by UL. Be wary of counterfeit products that may bear a false UL mark. Purchasing electrical components from reputable suppliers is one way to minimize the risk of obtaining counterfeit products. In addition to using UL-listed materials, proper conductor sizing is essential for a safe and reliable electrical system. Conductors, or wires, must be sized appropriately to handle the amount of current they are expected to carry. Undersized conductors can overheat, leading to insulation breakdown, fire hazards, and voltage drop. The NEC provides detailed guidelines for conductor sizing based on the ampacity, or current carrying capacity, of the wire. Ampacity is determined by factors such as wire material, insulation type, and ambient temperature. Calculating the correct wire size involves determining the load in the circuit, applying any applicable directing factors, and selecting a wire size with sufficient ampacity to handle the load. Wire size calculators and online resources can simplify the process of determining the appropriate wire size for a given application. Consulting with a qualified electrician is always recommended if you are unsure about the correct wire size to use. The use of ground fault circuit interrupters, or GFCIs, is another critical safety measure in areas where water is present. GFCIs are designed to protect people from electric shock by detecting ground faults, which occur when current leaks from a circuit to ground. When a ground fault is detected, the GFCI trips the circuit, cutting off the flow of electricity and preventing electric shock. GFCIs are required in areas where water is present, such as bathrooms, kitchens, laundry rooms, and outdoor outlets. These are areas where the risk of electric shock is higher due to the presence of water and conductive surfaces. GFCIs are typically installed in the form of receptacle outlets or circuit breakers. GFCI receptacle outlets are installed in place of standard outlets and provide GFCI protection at the point of use. GFCI circuit breakers are installed in the electrical panel and provide GFCI protection for the entire circuit. Testing GFCIs regularly is important to ensure that they are functioning properly. GFCIs have a test button that simulates a ground fault and causes the GFCI to trip. Pressing the test button should trip the GFCI, cutting off power to the circuit. If the GFCI does not trip when the test button is pressed, it should be replaced immediately. Arc fault circuit interrupters, or FSIs, are another important safety device designed to protect against electrical fires. FSIs detect arc faults, which are dangerous electrical discharges that can occur when wires become damaged or loose. Arc faults can generate high temperatures and ignite surrounding materials, leading to a fire. FSIs are required in bedrooms and other areas where there is a risk of electrical fires. These areas are often where people are sleeping and may be less likely to detect a fire in its early stages. FSIs are typically installed in the form of circuit breakers in the electrical panel. FSI circuit breakers are designed to distinguish between normal arcing, such as that which occurs when a switch is turned on, and dangerous arc faults that could start a fire. When an arc fault is detected, the FSI trips the circuit, cutting off the flow of electricity and preventing a fire. Like GFCIs, FSIs should be tested regularly to ensure that they are functioning properly. FSIs have a test button that simulates an arc fault and causes the FSI to trip. Pressing the test button should trip the FSI, cutting off power to the circuit. If the FSI does not trip when the test button is pressed, it should be replaced immediately. Providing adequate circuit protection is essential for preventing overloads and short circuits. Circuit breakers and fuses are overcurrent protection devices that are designed to protect circuits from excessive current flow. When the current in a circuit exceeds the rating of the circuit breaker or fuse, the device trips, cutting off the flow of electricity and preventing damage to the circuit and connected equipment. Circuit breakers are resettable devices that can be tripped and reset multiple times. Fuses are one-time use devices that must be replaced after they trip. Selecting the appropriate size circuit breaker or fuse for a given circuit is critical. The size of the overcurrent protection device should be matched to the ampacity of the conductors in the circuit. Using an oversized circuit breaker or fuse can allow excessive current to flow, leading to overheating and fire hazards. The NEC provides detailed guidelines for selecting the appropriate size overcurrent protection device for various types of circuits. Connecting neutral and ground wires correctly is essential for ensuring a safe and effective grounding system. The grounding system provides a path for fault current to flow back to the source, allowing the overcurrent protection device to trip and clear the fault. The neutral and ground wires should be connected together at the main electrical panel. This connection provides a low impedance path for fault current to flow back to the source. The neutral and ground wires should not be connected together at any other point in the electrical system. Connecting the neutral and ground wires together at multiple points can create a parallel path for neutral current, leading to circulating currents and potential safety hazards. Using electrical boxes properly is another important aspect of electrical safety. The electrical boxes are designed to protect wiring connections and provide a safe enclosure for electrical devices. Electrical boxes must be the correct size for the number and size of conductors installed. Overfilling electrical boxes can damage conductors and create a fire hazard. The NEC provides guidelines for determining the appropriate size electrical box for a given application. Electrical boxes must be securely mounted to provide support for the wiring and devices. Loose or unsecured electrical boxes can create a safety hazard. Labeling circuits clearly is essential for easy identification and troubleshooting. Each circuit at the circuit breaker or fuse panel should be labeled with its intended use, such as kitchen outlets or lighting. Clear and accurate labeling makes it easy to identify the correct circuit when performing maintenance or repairs. Labeling also helps to prevent accidental disconnections or energizations of circuits. Obtaining a permit and having the system inspected is the final step in ensuring a safe and compliant electrical installation. An electrical permit is required for most electrical work, including new installations, alterations, and repairs. The permit process helps to ensure that the work is performed in accordance with the NEC and local codes. An inspection is conducted by a qualified electrician or building inspector to verify that the installation meets the required standards. The inspector will check for compliance with the NEC, proper wiring methods, adequate grounding, and other safety requirements. Passing the electrical inspection is essential for obtaining a certificate of occupancy and ensuring the safety of the building occupants. The common problems identified by inspectors include incorrect wire size. Using wires that are too small for the intended load can lead to overheating and fire hazards. Inspectors will check wire sizes to ensure that they are in compliance with the NEC. Missing or improper grounding is another common problem. A properly grounded electrical system is essential for safety. Inspectors will check the grounding system to ensure that it is installed correctly and provides a low impedance path for fault current. Overloaded circuits can also cause problems. Overloading a circuit can lead to overheating and fire hazards. Inspectors will check circuit loads to ensure that they are within the rated capacity of the circuit. Improper installation of GFCIs or FSIs is another common problem. GFCIs and FSIs must be installed correctly to provide the intended level of protection. Inspectors will check the installation of GFCIs and FSIs to ensure that they are functioning properly. Unsecured electrical boxes can also be a problem. Electrical boxes must be securely mounted to provide support for the wiring and devices. Inspectors will check electrical boxes to ensure that they are securely mounted. Exposed or damaged wiring can create a safety hazard. Inspectors will check for exposed or damaged wiring and require that it be repaired or replaced. Absence of circuit labels can make it difficult to identify and troubleshoot circuits. Inspectors will check for circuit labels and require that they be provided if they are missing. Lack of documentation, such as load calculations, can also be a problem. Inspectors may require documentation to verify that the electrical system is properly designed and installed. By following these high-level tips and addressing the common problems identified by inspectors, you can increase your chances of passing the electrical inspection and ensuring a safe and compliant electrical installation.